So classified paper 2, topic 3.1, which is about the general properties of the waves. The first 7 already recorded, so we'll start with question 8. In question 8, what is the unit of wavelength? So when we check the options, hertz, that is a unit of frequency. Meter is a unit of wavelength. Meter per second, it is a unit for speed. And second is a unit for time. So that's why B is the right answer for this. Question 9, which row shows an example of a transverse wave? So in a transverse wave, the vibrations are perpendicular to direction of propagation, where in longitudinal wave, the vibration is parallel to direction of propagation. So all the electromagnetic rays, so if we, light waves are transverse, radio waves are also transverse. Radio waves are transverse, sound waves are longitudinal. Sound waves are longitudinal, water waves are transverse. Here transverse and transverse. So we need transverse radio here and sound waves are longitudinal. In question 10, a vibrating object produces ripples or waves on the surface of a liquid. The object completes 20 vibrations every second. So how many vibrations are there in 1 second? That's called frequency. So 20 vibrations in 1 second. So we have the frequency 20 hertz. The spacing of a ripples from one crest to the next is 3 centimeter. So means like these waves are there, from one crest to another, which is also called a wavelength. So wavelength is 3 centimeter. All the options are in centimeter per second. So we don't have to convert. If we need the speed, so how to work out the speed? Speed is frequency times the wavelength. So what is the frequency? 20. And what about the wavelength? 3. So 20 multiplied by 3, that will make 60, and the unit will be centimeter per second. Because the wavelength is in centimeter, that's why it is in centimeter per second. If the wavelength was in meters, then it will be meter per second. So vibrations per second is known as a frequency, and the spacing between the two successive crests or two successive troughs is known as the wavelength. Light travel at a speed of 3 exponent 8 in glass. In the glass, the wavelength of a light is 4.4 exponent minus 7. What is the frequency? So we have the speed and we have the wavelength. So we will use a wave equation. V equals F lambda, where V is a speed in a glass here, which is 2 exponent 8. F is a frequency. And the wavelength is 4 exponent minus 7. That's multiplied. Other side will be divided. So it will be 2 into 10 to the power 8 divided by 4 into 10 to the power minus 7. When you simplify this, this will give us 5 into 10 to the power 14 hertz as a frequency. In question 12, these are the wave fronts are there. A vertical stick is dipped up and down in water at P. So like this is the top view. If you look from the sideways example, there's a container or a ripple tank that is filled with water. So we use a vertical stick and that vertical stick we move up and down. So as a result, when we move this vertical stick up and down, so it will produce the waves or the ripples. But when you look from the top, you will not see the waves, you will see the wave fronts. And the distance between the two successive wave fronts, that is also a wavelength. Like this can be a wavelength or this can be a wavelength. So, and in 2 seconds, 3 crests are produced, 3 waves are produced. So what will the frequency? Frequency is number of vibration in 1 second. So in 2 seconds, so frequency is number of vibrations. So 3 vibration. If you want to calculate the frequency, it's the total number of the waves divided by the total time. So total number of waves 3 and total time 2. So the frequency is 1.5 hertz. So the frequency is 1.5 hertz for this. Now, which statement is correct? The distance x is an amplitude, is the amplitude of the wave. No, x is not the amplitude, x is a wavelength. The distance y is a wavelength. No, that's not the wavelength, that is twice of the wavelength. Like this is 2 times the wavelength. Each circle represents the wavefront. Yeah, that's true. Each circle represents the wavefront. And the frequency is not 3, it is 1.5 hertz. That's why C is the right answer. Is it clear, this question?
Yes, sir.
Yes.
Next question 13. Two men P and Q stands close to the gap in the wall. The man P cannot see the man Q, but he can hear. Which statement explains? So because what will happen when a man P at Q, he produces a sound. So when it passes through the gap, it will diffract, spread. And because of the diffraction, he is able to see. And for a diffraction, the wavelength should be either equal to, greater than, or equal to gap to have a maximum diffraction. First, because this is about the sound, so light, we don't use a light. So sound waves diffracted lot because the wavelength is similar to the gap size. Because when the wavelength is similar or equal, then it will diffract maximum. What about statement A? The light waves do not diffract. That is totally wrong. Light waves also diffract. Diffraction is a property of all the waves. So it's not only for sound, it is also for light as well. The light waves have a range of frequency, but sound has just one. No, that's wrong. Light and sound both have a range of frequencies. Sound waves of a higher frequency than light. Light is having a higher frequency. And even that does not explain the question. The question is related to diffraction and why the diffraction happen or occur, because the gap size and the wavelengths are equal. Question 14. Which quantity relating to a wave on the surface of a water can both measured in meter? So like both are having a unit meters. So when we check the unit, the amplitude is in meter, but the frequency is in hertz. So for frequency, it is hertz. Amplitude meter, wavelength meter. Amplitude meter, wave speed meter per second. Frequency hertz per second inverse and meter. So in option B, both of them can be measured in meters. In question 15, the diagram shows a graph for a displacement which has a larger amplitude and largest amplitude and the highest frequency. Amplitude is refers to the height. So when we compare A and B have the same heights, C and D are having a smaller height. So either A can be an answer or B. But what about the frequency? Frequency is refers to the number of vibration in 1 second. So on a same time scale, you can see A is having more vibrations than B. So A is having a higher frequency and A is also having a higher amplitude. That's why A is the right answer.